There's a place where the sea has no coastline to stop it, no land to break the wind, nothing to slow it down for thousands of miles. Sailors gave the winds there 3 names, and each one is worse than the last. The roaring 40s, the furious 50s, the screaming 60s. Picture a gap between 2 continents, about 800 kilometers wide, where South America finally runs out and Antarctica begins. This is the Drake Passage. Sailors have another name for it, the sailor's graveyard. Before the Panama Canal opened, almost every ship going between the Atlantic and Pacific had to run this gauntlet, and it's thought that around 800 of them never made it, taking more than 20,000 lives down with them. Just open water all the way around the world. That matters because of a thing called fetch. Fetch is the distance. Wind can travel across open water without hitting anything. In most oceans, wind builds waves for a few hundred miles, then slams into a coastline and has to start over. Down here, there's no coastline. The wind just circles the earth endlessly, pouring its energy into the sea the entire way. And that changes what kind of waves you get. Not the short, choppy waves you see at a beach. Instead, the wind builds long, deep swells, where each wave can be 12 to 20 seconds apart. That number sounds boring. It isn't. A wave with a longer gap between crests reaches deeper underwater and carries far more energy, and it can travel enormous distances without falling apart. In December 2024, a satellite tracked one of these swell systems, born from a storm in the North Pacific, rolling across 14,000 miles of ocean, straight through the Drake Passage, and out into the tropical Atlantic, still holding its shape the whole way. So you've got some of the most powerful swells on Earth arriving from every direction. Now watch what happens when they hit the gap, because it's not just waves squeezing through that 800-kilometer opening. It's also the largest current on the planet. It's called the Antarctic Circumpolar Current, and it moves somewhere around 135 million cubic meters of water every second. Let me try to make that real. That's roughly 600 times the flow of the Amazon River, not per Daltony, every second. And when that colossal river of water, plus those globe-spanning swells, get forced into the narrow gap between 2 continents, they have nowhere to go. The water compresses. It accelerates. The waves stack up into steep, towering, chaotic peaks. That's the Drake Passage. And on its worst days, it produces something that scientists used to think was a myth: rogue waves. For a long time, sailors came back with stories of single monstrous walls of water appearing out of nowhere, and nobody believed them. Now we know they're real, and we know roughly how they form. When waves moving at different speeds and angles overlap, sometimes one of them effectively steals the energy from the waves around it and jumps to several times their height in seconds before collapsing again. On the 2nd of March, 2001, a wave like that hit an expedition ship called the Caledonian Star head-on. It was measured at 30 meters, 98 feet. It smashed the reinforced windows of the bridge and knocked out the ship's navigation, and the crew had to be rescued by the Argentine Navy. 2 decades later, in 2022, a brand new cruise ship, the Viking Polaris, was struck side-on by another one near Cape Horn. It shattered the stateroom windows and killed a passenger. And here's the unsettling part. We understand the physics of how these waves form. We still cannot predict when or where the next one will appear. The ocean has been eating people here for centuries. In 1819, a Spanish warship called the San Telmo hit a storm in the passage, carrying 644 men. It vanished with everyone aboard. A year later, on a beach on Livingston Island, off Antarctica, sealers found the wreckage, spars, booms, and the massive anchor stock of a Spanish warship washed up on that frozen shore, which raises a haunting possibility. Scientists think it's likely that at least some of those sailors survived the sinking and dragged themselves onto that beach. If they did, then a group of shipwrecked Spanish sailors may have been the first human beings ever to set foot on the continent of Antarctica. They just didn't live long enough to tell anyone. So, the Drake Passage will kill you. But if you only see it as a hazard, you're missing what it actually is. Because all that violence is a side effect of something much bigger. Follow the current down, away from the surface, to the jagged underwater mountains on the seafloor, like the Shackleton Fracture Zone. When the deep water is forced over those ridges, it creates enormous waves far below the surface, waves you'd never see from a ship. When those hidden waves break, they violently stir the ocean, mixing the cold, deep water with the warmer water above it. And this specific region does something staggering. Roughly a fifth of all the wind energy the entire global ocean absorbs gets burned off right here, in the Southern Ocean. That mixing is one of the engines that keeps the world's ocean conveyor belt turning. The vast circulation that carries heat from the equator toward the poles. Climate models suggest that without an open, turbulent Drake Passage doing this work, that conveyor belt could stall. The chaos you see on the surface is the sound of the planet's climate machine running, and it goes deeper still, back through time. Tens of millions of years ago, South America and Antarctica were joined, and there was no Drake Passage at all. Antarctica wasn't frozen. When the continents finally split apart and the water broke through, that circular current formed for the first time, and it wrapped around Antarctica like a wall, cutting it off from the warm water flowing down from the tropics. Sealed off, the continent got colder and colder until it froze into the ice sheet we know today. If that gap had never opened, some scientists think Antarctica might still have forests. So the next time you picture the bottom of the world, don't just picture the ice. Picture the narrow, screaming stretch of water that put it there. The most violent crossing on Earth isn't a scar on the map. It's the machine that quietly decides what our whole planet feels like. And it has never, for a single day, stopped running.